This is a story about signal transduction, but we're just going to make it a little bit more interesting by combining it with the movie Finding Dory. Anyway, Dory is trying to get to the center of the cell to tell Marlin that she found her parents. However, since she's a large nonpolar molecule, she can't pass straight through SeaWorld, which is acting as the membrane in this situation. So instead, she has the proteins, which is her friends, help her to get inside. So Dory decides to take 4 different pathways: G-linked receptors, receptor tyrosine kinase, ion channel receptor, and epinephrine pathway. The first one we're going to talk about is G-protein linked receptor. So this is G-protein linked receptor. Now, how this ends up happening is that Dory, who is the ligand, activates the sea lions, which is the receptor, which in turn activates the G protein, which is the bird, which then activates the enzyme, which is the octopus. Hank then causes a phosphorylation cascade to happen, activating many different other proteins, like Destiny, which is changed by the presence of phosphate. This phosphorylation cascade will eventually lead the message to the nucleus where Marlin is hiding out, and the message will finally be received by him. Okay, so earlier we talked about a G protein receptor. Basically, the purpose of the receptor is to combine with the ligand, which eventually activates the G protein, which then activates the enzyme and causes a chain reaction. In this situation, the receptor was Becky the bird, which is represented as the white bird in the cell. Another thing we talk about is the cascade. The cascade is a multi-chain reaction that produces phosphate, which help activate each protein, one of those proteins being Destiny, by changing its shape. Okay, so the next one we're going to have is the receptor tyrosine kinase. Now what happens here is that the ligand, still being Dory, attaches to the 2 proteins, which is represented by the seals, which that is the tyrosine proteins, and they come together and form a dimer. And that dimer ends up being activated by the phosphate that comes from ATP. That phosphate can form 6 different links to the tyrosine, 3 on each side, which then later activates Destiny and then brings the message to the nucleus or to Marlin, saying that Dory finally found her parents. Now, the thing about a receptor tyrosine kinase is that in order for it to work, both proteins have to be present, because one protein has half of the message and the other protein has the other half of the message. The message can't be transmitted without both proteins coming together. Now, in order for a protein to become activated or deactivated, all you have to do is just add a phosphate or get rid of a phosphate. That will change its shape and prevent it or allow it from transmitting the message. Okay, so the next one is, I believe, the easiest one out of all these to know, which is the ion channel receptor. So with the ion channel receptor, basically what ends up happening is that Dory, still the ligand, combines with the sea lion, which is the receptor, and that receptor sends a message to the membrane saying it to open its gates in a different part of the membrane. This allows other molecules to come in and relay to the message to Marlin, which is in the nucleus, saying that Dory found her parents again. Okay, so our next and final pathway we're going to talk about is the epinephrine pathway. The epinephrine pathway basically involves this. Dory, which is still the ligand, combines with Destiny, which in this situation is acting as the G protein linked receptor, and then Destiny then activates the G protein, which is Hank in this situation, the octopus, which then forms with the enzyme, the sea lion, which then causes a phosphorylation cascade to go on in the cell, which eventually would lead the message to Marlowe in the nucleus saying that Dory, of course, found her parents again. Yippee. Now, epinephrine is just another name for adrenaline, which is considered the flight or fight hormone, and that usually occurs when you're being chased by an axe-wielding maniac and you decide to run. Okay, so that is our last signal transduction that we have to talk about. And honestly, if I was Dory, I probably would have given up after the G protein linked receptor. But just keep swimming.